work. Maybe we can click I'm connected. All right. Welcome, everyone. Good morning. My name is Tyler Jewell. I am here to introduce Eclipse Che. Thank you for listening to this jet-lagged American speak for 30 minutes here. 35 minutes is a very short amount of time, so I'm going to rapidly go through this here. How many of you are developers? Everybody. Is there anybody, I mean, let's do the opposite. Anybody not a developer in here? Okay. What do you do? Out of curiosity. You delete a developer project. Okay. So kind of the same thing here. Okay. We have a much more elaborate version of this presentation that we can go in. But I'm just going to dive right into the basics here and get right into the demo. Eclipse Che is an open source workspace server. It provides high performance and customizable workspaces. And those workspaces are accessible either through SSH or through a browser IDE, which is also part of Eclipse Che. Eclipse Che is part of or it's built on a plugin framework that's very similar to the way the RCP works. But instead of building desktop IDEs or desktop plugins, the plugins here are compiled into both server-side extensions for this system and also browser-side extensions into JavaScript. The experience is going to be what I'm going to show you. I'm going to dive right into the demo of what the developer experience will be like, and then I'm going to go into the architecture of why it was designed the way it was. There's a lot of stuff that's going on here, and we'll then open it up to questions about that. Okay, so here we go, Eclipse Che. I'm running Eclipse Che on my desktop. This that we're showing here is not yet a released version. This is what we call Che 4. Che 4 is a next generational rewrite that we started about a year ago. There was a previous version, Eclipse Che 3, that's been out there, and I think we're on version 3.13 at this point in time. It has a pretty fundamentally different architecture from what we're going to show you here, and what's going on with this project. I have an IDE. As you can see, it's in the browser, right? You can see some URL up here. I can zoom in. Is that big enough for those in the back there? Is that somewhat readable on that? We're going to see some errors on this. That's OK. I'm going to clean out some of these event logs. But this is fully in the browser. This editor that you see is an Orion editor. We use a variety of different Orion editors for different capabilities. And when I type, it's got virtually the same sort of editing speed that you would have with Notepad, VI, or Emacs on there. So very responsive to my keystrokes. I have, since it's an Orion editor, I've got the file navigator over here. You can see that we've got some pop-ups to explain. Like this blue thing here indicates where the current line is. And there's some other things that are going on. I have imported a project here. This project was an executable jar file that was hosted at GitHub, so I just imported it. I set the project type to be Maven here. And this project basically has a single file that has a simple hello world in this package here, and it's ready to go. The IDE itself has IntelliSense built into it. And where this gets interesting is when you ask me the question, how is IntelliSense working in the browser on this? And we'll explain that a little bit later. But that IntelliSense was fairly instant that you saw there. I could do a new create object. I can say this is my object, and you can see that you get the find on that. And it's giving me the syntax errors right away. And this is pretty instant here. Now, when I work on these files, I am not saving anything. I'm just typing away, and the system is automatically saving it as I go. And so what it's doing is it's capturing my input, packaging that up, and then streamlining it over to the Workspace server, which is managing this file tree for us. I'll explain a little bit more about how it's doing that in a minute there. We can do interesting things like, let me turn off my function lock here. Right, oh, sorry, wrong function. Alt-Enter. It's the wrong sort of. We get all sorts of autocomplete. So I can do system dot control space. We get the various autocomplete capabilities here. There are other things that we can do. So let's go ahead and create a public int field, right? It will instantly identify that, it should instantly identify that that field is not used. It's not. We can do an import org, and it gives us the list of classes that are available here on that. I do that, and it gives us the import is never used automatically. I can put here, is it Alt-Enter? Nope.
Well, you had a public field and a public class, so it is not wrong.
Yeah, let's see if I made it private. There you go. Thank you. Alt-Enter. There we go. Get the pop-up. So Alt-Enter on this, and then we can remove unused imports, or I could add an @suppress warning on this here. So lots of different variations of IntelliSense. Another thing that I just want to quickly point out on this is I'm going to go here and create a new Java class. We're going to call this my class here. And now I'm going to go into my class, and let's just give it a public int my field, public void my method, and we can do that here. And I haven't saved anything, and if I come over here, I could do my right away, and it's already picked up on this. So I'm laying some groundwork here, but in order for all that to happen, there was a class that was created. I had to edit it. It had to save those files somewhere out in the ether of what's going on. The syntax analysis had to run on that, and then that syntax analysis had to be immediately available back to the browser on the client side, and it's pretty instant. We're able to use Che to build Che, so we have files that are thousands of lines of length, and the performance doesn't degrade on this, right? So it's about the same on this. But I can go my class MC equals new, if I can type today, there we go. Typing is awful today. Huh, I locked it up. Demo gods. There we go. Oh. That's interesting. My browser locked up. There we go. New by class, and then MC dot my field and my method should be there. There we go. Okay. All right. I can do things like format this, no problem. We can also get into interesting things like highlight this and Shift F6 one time, and I could rename that. Or if I wanted to get really fancy, we could go in here and we have refactoring built into it. So we could name it from my class to my class team. We'll come in here and take a look at the preview. On the preview, we have a diff editor. This is the Orion diff editor. Shows you what changes that are going to be there. Let me zoom out real quick. Click OK on this and zoom back in. And what I'll notice is that it renamed my class to my class team. It's got it renamed up here. It's renamed in the file system as well. So all instantaneous on that. Okay? So basic IDE. How do you build in a cloud IDE? Right? Well, what's interesting here is we have a concept of what's called a command. What's really going on with this is that when this Workspace server boots, it's this magical land of workspaces that are out there, and it's on this, the workspaces are on the server. When you go and create a workspace, in Che, or in a cloud environment, the workspace needs to also marry itself to an environment itself. When you use the Eclipse IDE on your desktop, the environment is localhost. The IDE assumes the environment is already there. It's installing on top of that environment, and then it binds itself to that. In a Cloud IDE, there's no such local host available to it. So every time we create a workspace, the workspace has to be bound to a new environment. And so I skipped it here, but when I created this workspace, it asked me, hey, what environment do you want this workspace to be part of? And I just chose this is a Debian environment with JDK8 and Maven and Git and some other things that were part of that. But that environment was magically bound. We use Docker container. We use a Docker container as an implementation to create these environments and then bind it into the workspace. When a workspace and an environment is bound together, there's a bunch of magical things that happen. One of the things is that your workspaces and your projects are mounted into that environment. And there are other things that happen as well, such as the ability to send commands directly from the IDE into that environment that you control. So let's create a command here. The first thing I'm going to do is commands can have a type. And I'm going to create a command of the type Maven. And we're just going to call it build. And this magical language here is a templating thing that gives you a way to reference files and folders and modules from your project inside of this environment. And this is the command line. And I'm just going to apply that, go OK. And now we've got this magical build command. And what this says is we would like to send the build command into the environment named dev machine and see what happens here. And we do that. And you see that it's, there's a little Maven gray thing there. And what it basically did is it took that command, it compiled it into a process, injects it into the environment itself, and now that environment is honoring that command. And this particular command was a Maven clean install. And it is as fast as anything on localhost. The process of injection is about 200 milliseconds here on that. And then within the environment, it is localhost speeds. Now, this is not going as fast because we have conference Wi-Fi, right? But it's doing downloading all this sorts of stuff here. But it's going to compile that. What's that? Oh. Once it gets done building, we're going to need to run it. Right? So let's go and create a run command here. So we'll just call this run. And it's a Java executable, so java-jar. And the directory that we need to do it is in /project/g/target/hello. I'm just going to guess at 1.0-snapshot. I'm just guessing that this is the jar file on that. So I'll save OK on that. But hopefully this download gets done in a second. But while we're waiting for that, let's introduce the next part of Che. When you get into the Cloud IDE world, there is a dual perspective view that we have to start worrying about. There's the source code view, which is what we're all accustomed to. Projects, files, folders, modules, editors, builds, and runs. But at the same time, your workspace is managing one or more environments. Now, when we booted this workspace up, there was one environment that was magically bound into it, but your workspace can actually have as many environments as you want. You can have a development environment, a test environment, a production environment, and you can map your source code into any one of those environments that you'd like to have. Those environments can be single machine or multi-machine. So you could have a cluster of 3 containers running in a single environment and then send your commands into that to execute against your source code. I only have one machine installed here, but we've got a root access terminal that is available to us here. And it's a full terminal, and it's pretty responsive. I could run Midnight Commander here if you're a fan of that. I'm just going to exit this here. And so I'm going to clear. Where's my directory? And so I just want to verify where that code went. So there's the projects directory. There's my project, which is what we were looking for. We've got some formatting to do, as you can see here. But then there was the target. And there it is, hello world-1.0-snapshot.jar. Here, exactly where we want it to be. And just to show you that I'm not playing around with you, there we go. So now we're in this directory. Let's just touch something fun here, eclipsecon.java. Go back into our thing here. Just do it for fun. Oh, there it is, eclipse.java, right? It's dually mounted. That was a root access terminal into that environment, and you can run Rails, scaffolding commands. You can SSH into it. It's available for you to do. So back to our build command. We finished the build command. Everything looks good. Let's run it. Hello world. All right. I've never done it that fast. As you can see, I am not a developer by trade, but my fingers are moving pretty darn fast. And other than that one browser hiccup, the speed is pretty close to localhost speed. We have put a lot of time and effort into giving this experience as close as anything as you can get with Eclipse or IntelliJ. How do we do that? All right, I'm going to get into the architecture about how we do lots of crazy stuff. But any questions about the developer usage of this to begin with? Yes, sir.
I have a question. How would you develop applications that have a desktop UI? Because it's running.
Yeah. So the environments are all defined by a set of machines which have recipes. Now we provide a Docker implementation. So in that Docker implement, you can provide your own Docker files. So you can launch an environment of a Docker. I'm going to answer. Yeah, I understand. Like we do this with Android, by the way. In that Docker file, you can launch a VNC server. And that VNC server, when the environment boots, you can have that VNC server active, and then you can advertise that URL. So VNC, of course, is not the great. Like if you're doing a Swing app and whatnot, you're going to have some performance issues, but it gets it running entirely in the system, and it makes available to that. Yeah.
What happens if my browser crashes and I haven't internet connection? There is some local offline.
So I'm running Che in an offline mode here. Okay. Codenvy, my company, we take the same sort of plugins and we run a destination place, like a big massive cloud of this sort of stuff. It's not available today, but we are pretty darn close to giving you workspace portability, meaning that you can take any workspace that's running on your desktop and move it to a Codenvy installation or back. And then one of the things we are going to work on with the Eclipse Foundation is the Eclipse Foundation is working on having a profile storage for users. So we'll let you take a Che workspace, move it up to the Eclipse Foundation storage for safekeeping. So you're going to need to be able to gain access to that workspace, either through some internet connection or download it. But once you have the workspace, then you can continue your work. The issue that you run into is that if you need to do a GitHub, if you need remote access, we can't help you with GitHub clone or whatnot. But all those environments, the images that go with them, the source code, once it's downloaded here, it's completely offline if you need it to be. Right? Okay. Thank you. I hope we are registering on your cool factor so far. What was the goal? Why rebuild the Eclipse IDE using a browser IDE? I get this all the time. People look at me like, you are absolutely nuts. My company, we are now over 3 years old. Founded it in 2012. We raised $10 million of venture capital. We are well funded. We have about 50 employees, most of them in engineering. We have about at least 20, maybe as high as 30 people working on Che all the time here. There are a lot of outside contributors to it as well. The reason that there is so much interest in this is that the goal is quite simple. What if we could let anybody contribute to any project anywhere at any time without ever installing anything? And it just always worked. If you just thought about that, right? If just without ever installing anything, what would it take to do that? And what it would take to do that is you would need some magic. URLs are the answer. URLs are the universal exchange of information. Let's imagine you had some magical URL, some domain, and we just append this label here, factory. And after that factory, it would indicate an ID of a workspace or a project that you would like to work on here. What would need to happen? When you clicked on that link, the system behind the scenes would need to have the smarts to create a new or load an existing workspace, populate that workspace with projects that have source repositories that could come from Subversion or Git at any remote location. So that means there's some intelligence about getting the source, setting up the branch, pulling, doing the fetch. Then on top of that, you're going to need every developer tool that is necessary to work on that project injected into the workspace. It then needs a runtime environment automatically created that can actually execute the commands of this. And then you have to put the developer into the workspace. And so if you don't want to install anything, obviously you need a browser experience for the onboarding. But then behind the scenes, you need an elaborate server to do all that automation on that. And that's what we did. So Codenvy makes this technology we call factories, which is an automation engine for connecting anybody through Jira or Jenkins or GitHub from that starting point and just clicking on a link and ending up in a workspace that looks like what we just saw. Che itself, I don't have time to do this demo, but I want to get into Che. But Che itself is the workspace that gets created. It is the IDE for interacting with it, and it's all the tools and environments for executing it. Codenvy just takes Che and makes it run at scale with this automation workflow built into it. But what is going on with Che? So first you've got a Che server. We run it on Tomcat. You can actually use other web servers with it as well. The IDE itself is written in Java, but it is then compiled into a WAR file. The actual UI is transpiled into JavaScript. And there's a big WAR file. It's just called che.war, and it's sitting on the server. And when the browser registers, it actually downloads the JavaScript. It caches it into the IDE. And the IDE itself provides a very thin interface for editors, panels, menus, widgets, all the sorts of things that you saw. There's a UI library that's available there. The IDE then is working against a set of RESTful APIs that are hosted within the Che server. These APIs are managing the workspaces, create new workspaces, and it's also managing the environments, create new environments. The workspace itself has a set of projects inside of it, the files of which are saved in some sort of file system. We call it a virtual file system. Those workspace files are also dually mounted into what we call a machine. The environments are defined. You have a development environment, a test environment, whatever they are. The environments depend upon a set of machines. Now, the machines are things that run outside of Che. We provide two implementations of machines in our default implementation. One is the Docker implementation, which is what you saw me using. But you can actually, when we finally ship this, swap out the Docker implementation for localhost. And if you have a localhost machine, then the Che is operating just like your typical desktop IDE. Che has intelligence for starting the machines, mounting them, binding to them, and making sure they're available, and then putting your projects inside the machine itself. Now, there's actually a little bit more that's going on with it. Inside that machine, there's actually three things that can go on. You have the mounting of the projects, and you saw that we were able to go in there and modify them directly. You can SSH into it or inject a process. So in the Docker syntax, this is called a Docker exec. But you can actually take a process, actually execute it here, and this process has access to the file systems or to embedded Che services. But then the other thing that we do is that when we launch a machine, we install a second instance of Che. This is where your head starts to explode, into the machine itself, right? Well, what we actually do, we're actually installing another Tomcat instance, and inside that thing, we call them Che services. And these Che services vary based upon the type of project that's here. So if you have a Maven project, we have Java services that get installed. If you have a PHP project, there's all kinds of different services, and they advertise themselves on APIs. When, you don't see it, but when I said starting the workspace, you'll see extension server booting, and that's this thing here. The IDE, when we do a refactoring command, it's kind of flowing through, and it actually invokes this Tomcat server that's in here, and there's a refactoring API, and what we've done is we've taken the JDT core out of the Eclipse IDE, we've made it multi-tenanted and wrapped it with RESTful interfaces on it so that we can access it in a decoupled way, and then those commands are executing against these local files here, and that's what gives us the same speed and performance out of that. Also, on top of that, Che ships with an SDK. There's an extension framework. When you write an extension for Che, you can write it in Java and JavaScript and CSS. It gets packaged as a plugin. That plugin can include a bunch of other stuff like code templates and environment definitions and whatnot. But you then can take Che core plus some set of plugins, compile them all together, and you get an assembly. And then this assembly is distributable as a desktop app. We're going to make an Electron Atom packaging of it available so that you can just hand it off to users and they can click and install. Or you can run it as a mini server there on that. But with those extensions and plugins, right, there are 3 types of extensions that you can write. So there's a single format, but when you write an extension, you write Java code, and I can give you a sample of what that looks like. But based upon dependency injection and annotations that you provide, it then tells the extension that when it's packaged into an assembly, is it an IDE extension, which gets compiled into JavaScript? It can be a workspace extension, which modifies this behavior, or it can be a project type extension, which injects services based upon that project type into the machine for use. So it could be like C++ annotations or PHP. You have the total flexibility on this. The entire IDE itself is a grouping of about 30 or 40 extensions that we've been building over the years. Our big goal, we are within like weeks of making our first official Eclipse release. It's taken us 9 months, 150 CQs. We have, that's a known bug. The timing is perfect because it's non-recoverable, but that's okay. Get back to my presentation. We are, thank you. We are like 5 CQs away from completing our first release. And it's only going to be on 3.13. What I've been demoing is 4.0. You can build this yourself. Git clone this repository, check out 4.0. It'll Maven clean install. It's ready to go. You do need to have Docker installed. We have instructions on the Eclipse Che website about how to get Docker installed and how to have it set up if you're on Mac or Windows. It's tricky. It's tricky. But we are huge over our big goal is to, by March, to make 4.0 as hardened and as stable as humanly possible. We would love to broaden the community. We're about 50-ish developers now. We'd love to get people involved, even if it's just QA and hacking. We're going pretty hard. Unfortunately, our engineers revolted and refused to use Bugzilla. And so we lobbied pretty hard, and at the Eclipse board meeting this week, they agreed to let us use GitHub issues for issues. So we've got about 1,000 Che issues in our Jira, and we're going to migrate them all to GitHub over the next couple of weeks. So that'll open up everything for the community to be a part of. And we're excited about that. And then I have some other stuff on the code itself. But any questions? Let's just take 5 minutes and go through questions. Yes, sir?
What are you using to transpile Java to JavaScript?
Google Web Toolkit.
Oh.
Yeah. We have a prototype of us running on Vaadin, and it works. So I think for 5.0, probably our big exercise will be to make a Vaadin implementation, which is really nice because if you've ever done anything with Google Web Toolkit, there's a lot of kind of recompilation. It's somewhat difficult. But the Google Web Toolkit is only required for the IDE portion. You can run this completely disconnected on that. Right? Yes, sir.
What's the equivalent of a launch configuration and a target platform?
So you might need to describe for me what a launch configuration is.
Well, when I have to run my project
Okay.
in Eclipse, and when I'm coding against a target platform, so how would that work? Is it kind of like a flexible way to like redefine a common dependencies and the environment,
okay.
libraries and APIs and so on.
Yeah, I don't think
which version of Eclipse am I coding against or projects?
Got it. No, we don't have that abstraction yet. I think the only real thing that you have available to you now is that you can have any type of command that you want, but you'd have to reconfigure each command for a different launch configuration. But that command type is a clean abstraction, and we can create many different types of commands, and so we can probably just add the same sort of capability here on that. But we're not there yet. Our focus, by the way, has just been, can we import every Java project on the planet, and will it compile and run on that? That's kind of job one with us. Yeah, sir?
Do you have to patch anything in JDT core to make this REST API work?
I believe we did have to do quite a bit of stuff. The engineer who did that work is here, actually, so I'm sure he'd be happy to share. We'd love to, in our kind of wish list, we'd love to see the JDT core, the PHP development tools, the C++ development tools, and some stuff from Microsoft all come together into kind of a common language core. And then we could put a common REST API that we've basically got here, which allows for multi-tenanted access. We'd be over the moon with something like that. Because if you had a common core with a common interface on all that sort of stuff, it just becomes pluggable, and you can add tooling for a wide range of scenarios. Yeah?
Yeah, okay. Like one of the advantages from the launch configuration is, I think, is also that you can check them in together with your project. Can you just, any of the commands share together with your project?
Yes. So all that configuration is stored in your workspace definition. And that workspace definition is in a .che file in the in the workspace directory, so you can check that in. In the case of Codenvy, where we use the factories to generate things from scratch, the factory definition is actually stored separately in a database. It's kind of like Puppet or Chef. And so you can define the state, and with that state, you can include your command definitions with that as well. So that when we say you click a link and it's exactly the way the other guy was using it, we mean it's exactly down to the pixel and command structure that the other guy had, so that you can just pick up where he left off on it. All right, thank you guys. I'm very interested in your feedback, by the way.